Okay, welcome back. EENG 460. That's hard to say. EENG 460. Try saying that 10 times. EENG 460, number 11. Last time we did a load word. And when you say load, you're always referencing the register. So load what? Load register. Load register, that means you're taking stuff from memory and loading a register. Now there's another command called the store word command. And again, it's referenced to a register. So you're storing a register. Where are you storing the register? You're storing it in memory. So load word brings it from memory to the register, and store word goes from the register to memory. Okay, so this program shows you how to use the store word, and it stores data to memory. Okay, now we have our usual parts. Got my little comment section up top. I have the data segment here, but notice I'm going to use store word to write data to memory, so I don't need to declare anything. I'll just actually write it to memory. Okay, then the next part is the text segment. Okay, and then we want to label the main program with a global preprocessor directive. And then of course, what do we have down here at the end of all the programs? We have exit the program. LI V0 load immediate, V010 says call. All right, all that, you want that at the end of all your programs. All right, so let's talk about the store word command. What does the store word command do? Well, what the store word command does is it takes the contents of T0 and it writes it to memory defined by this address. And the way you read this is the contents of T1 is a memory address. Add an offset of 0 to that, and that's the memory address that you're going to store the contents of T0 at. For example, this one here says, look at the contents of T1. That's a memory address. Add 4 bytes to that. That resulting memory address is where you're going to store the contents of T0. Okay, down here. The contents of T1 is a memory address. Add 8 to it. The resulting address is where you're going to store T0. And then down here, same thing, but now you're going to offset 12. This is your base address. The contents is your base address. You're going to offset 12 from there. That's going to give you a new 32-bit address, and you're going to store T0 there. So when you look at this code, what I'm really doing is I'm setting up T0 with a value, and then I'm writing it to memory. So here I increment T0, and then I write it to memory. Here I set T0 to 1, 2, 3, 4, 5, 6, 7, 8, and write it to memory. And then here I set it with A5, 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 and I write it to memory. All right? Let's just go ahead and open this guy. Let's go over to here and do File, Reinitialize, Load, and this would be a store word. Okay. Now let's go look at our data segment. Do we expect anything to appear in the data segment? Well, no, we don't, because we didn't put anything in the data segment in our code. All right. Let's bring our code back up here and verify that. The data segment was empty. Okay. All right, let's go look at our text segment. Well, there's our code. All right. So let's hit F10. First thing we did is I loaded T0 with hex 30. All right, let's go look at that. T0 should have hex 30, and it does. All right. Let's go back and hit F10. All right. Now when I hit F10 here, what am I going to do? I'm going to do a load immediate again, but this time I'm going to load T1 with 1001 quad 0. Why am I doing 1001 quad 0? Well, because that's the location I'm going to write data at. All right, let's hit F10 here and verify that T1 now has 1001 quad 0. T1 has 1001 quad 0. Why do I want 1001 quad 0? Because that's where I'm going to write in the data segment. Right now, there's nothing at 1001 quad 0 because all these locations are 0, and 1001 quad 0 is in the middle there. All right, so now I'm going to use my store word command, and the store word command is going to say, well, get the contents of T1, which is 1001 quad 0, add 0 to it, which is still going to be 1001 quad 0. That's a memory address. Store T0 to that memory address. Well, T0 is a 30. So what's going to end up being at that location is 30. Let's hit F10 and go check the data segment. And there you go. We just wrote 30 to location 1001 quad 0, but it did a 32-bit write. It also wrote those upper 24 bits too. It's a 32-bit write. Okay. All right, now let's come along here, and here's a command you haven't seen before, I don't think. Add immediate. We talked about add command, which adds 2 registers and stores the result in a third. Well, the add immediate takes the contents of one register, which we know is 30, and adds 1 to it, and then stores it back in this register. So T0 is going to be 31 after we do that. Add immediate. All right, let's go check T0, and it is 3-1. Good. Let's go back to our program. Now what we're going to do is we are going to store T0, which is currently 3-1, to T1, which is 1001 plus 4. So I'm going to write T0 to 1001,0004. Base address plus an offset. Store T0. T0 is 3-1. Let's go look and see what's at 1001,004 before we do the command. 1001,004 is this guy right here. Okay, there's nothing there. Let's hit F10 and go take a look and see our data segment again. There you go. We just wrote the contents of that register, which is 00000031, to that location, and then it filled in the other 24 bytes for us. Okay. Now let's put a 32-bit number in there. Now here what I'm going to do is I'm going to put 1, 2, 3, 4, 5, 6, 7, 8 into T0. Okay. Let's go look at T0 first. T0 currently has 31. All right, let's go back to our text segment, and I am going to hit F10. I'm single stepping through it. Got to do it twice. This command maps to 2 actual MIPS commands, so I had to hit F10 twice. I'll explain that later. It has to do with the sudo command. So now T0 should have the contents 1, 2, 3, 4, 5, 6, 7, 8. Let's go check it out. There's T0. 1, 2, 3, 4, 5, 6, 7, 8. Great. All right. Now, here I'm going to take the contents of T0, which is 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to store it at the memory address T1, which is equal to 1001 quad 0 plus 8. All right, let's go look at our data segment. This guy right here is 1001 quad 0. This is 1001,0004. This one is 1001,0008. So we're going to write 1, 2, 3, 4, 5, 6, 7, 8, a 32-bit write that's going to start here at 8 and go to 8, 9, A, and B. Let me hit F10. And let's go see what happened at 1001,0008. And there you go. We just wrote it. We started here at 8, 9, A, and B and wrote that 32-bit quantity. Okay. What are we going to do next? All right, now I'm going to load T0 with A5, 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 A5. Okay. Let's go look at T0. A5, 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 A5. And now what I'm going to do is I'm going to store that at 12 bytes past my offset of 1001 quad 0. So it's going to go to 1001,000C. If you go to your data segment, that would correspond to this location right here, 1001,000C. When we execute that statement, I'll F10, step over. We should get A5, 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 A5. And there you go. Yeah, and we just wrote to memory. We didn't use our data segment. We actually used the store word command to take a value in a register that we put in with load immediate and then write it to memory. Now notice, remember the 000s, those are all unprintable characters, right? And then you've got a 30 here, right, which corresponds here. And then the 31 corresponds here. And then you got the 3 non-printable characters. It's kind of backward over here. And then let's see, the 78. Okay, 78 actually corresponds to an X. You can double check me. A 56 corresponds to a capital V. A 34 corresponds to a 4. And a hex 12 is an unprintable ASCII character, which is going to be represented as a period. And also A5 is an unprintable ASCII character, which is going to give you the dots right there. All right, nice. And then we just do load immediate V010 to terminate our program. All right, and as we start using procedures, it'll make more sense why we always do that V0 load immediate 10 to terminate. Well, that's enough on store word, but store word basically takes the contents of a register and writes it to memory. All right.